Hello everyone, welcome to the sixth tutorial session of problem solving through programming in C. So this is a SWAYAM course which has been floated by Professor Anupam Basu from Department of CSE IIT Kharagpur, and I am Siddhant. I am one of the three TAs who are in charge of taking these tutorial sessions, where we will very briefly discuss the week's lectures and and discuss a few questions which will help you out with the assignments as well as the final exam. Okay, so for the week 7 lectures, we covered strings as and 2D arrays. So we'll be solving a few questions regarding the same. So first we talk about 2D arrays. So 2D arrays are nothing but multiple. So if you have a 1D array, you can think of many different 1D arrays coming together to form a 2D array. So in 2D array, we have rows as well as columns. For example, the question on the right hand side here shows you a 2D array which is of the dimension 3 cross 4. That means uh, it has 3 rows and 4 columns, and they can be initialized in this way, which is 5, 6, 8, 2, which is the first row. Then the second row 4, 5, 3, 7, and the third row 1, 10, 13, 15. So this is basically the array that we have written here. So this is a 2D array of dimension 3 cross 4. The row dimension is always mentioned first, followed by the column dimension. So keeping that in mind, let us answer this question. It's theoretical in nature. So what is the placement of elements of a 2D array in C? So what that question means is basically if you have a 2D, if you write a 2D array in C, in which way are the elements being saved in the memory? So what do you think should be the answer here? You can probably unmute and answer, or you can write it in the chat as well. So C is something which is called a row major language, or it follows a row major format for 2D arrays, while languages like Fortran are column major, and languages like Python can use either row or column major depending on, like, you can specify in which format then the commands or the functions need to consider it. You can specify that. So but in C, in the 2D arrays are considered in a row major format. What does that mean is so answer here is A. So what does that mean is that if you have a array which is, say here, I have an array which is 3 cross 4, in the memory, however, it is stored in in a format which is 12 cross 1, where the storage would be in this sense. So 5, 6, 8, 2, then 4, 5, 3, 7, and 1, 10, 13, 15. So this is what I mean by row major. So that means every row is considered, the major dimension is the row and the column is the secondary dimension. So all the elements are considered in the following way. So you have the entire first row being considered first, followed by the entire second row, followed by the third row, and so on. So the in the memory it is being stored in this format. So that is why it's called a row major format. Okay. So this is how the placements of elements in a 2D array is in C. Uh, so keeping that in mind, let us just go and answer the second question as well, because this is quite straightforward. So we have this array which is 3 cross 4, and we are printing a element which is 2 cross 3, I mean 2 comma 3. What does that mean? So these are the indices. You have to remember that these are the indices. So indices for both the row as well as the column starts from 0. So if I write the indices here, so 0, 1, 2, 3, these are the column indices, and 0, 1, 2, these are the row indices. So this is the row index and this is the column index. Now the first index here is the row index. So row index is 2. Row index is 2 means the third row. That means this is the row that we are looking at. And then the column index is 3. That means you're looking at the last column. So you have the value which is 15. So 15 would be printed here. 15 would be the output for this particular problem. Is it clear to everyone? Okay, so I'll be moving on to the next question. So this is also related to arrays, but it's not related to 2D arrays. However, we will be using a concept here which we covered in the previous tutorial session as to how this the array referencing operator works. So what do you think should be the answer for this particular, I mean, what should be printed if you execute this particular code? 40. Okay. So let us write down the indices. So I have an array which is a array variable a, which has a element. The number of elements of the array is 20, and I'm specifying 6 elements here, and the rest of the elements are automatically set to 0. Okay, and so on. And I am printing 3 of a. So this looks pretty odd actually, but what the compiler sees whenever you write any such statement, when you write a of b, what the compiler sees basically is this basically. That means you are referring here, a refers to the first to the address of the first element of the array, and plus b meaning it will shift that pointer to different array locations. So here you have 10, 20, 30, 40, 50, 60, and then 0, zeros and stuff. So when you said, if I write a of 3, this is quite a valid expression. I mean, this is quite understandable that a points to 10 initially, because that's the first element. So if you just write a, that means it's the address of the first element of the array. That is the address of this whatever memory location is storing this value of 10. Now, if you when I write a of 3, that basically means it's this. That means I'm shifting this by 3. So 1, 2, 3. So this is a plus 3. So a plus 3 basically means that the address of the fourth element of the array, right? If I write a, then that means the address of the first element. If I write a plus 3, that means it shifts it by 3 elements, shifts the pointer by 3 elements, and I'm currently referring to the address of the fourth element of the array. And then because this is supposed to give you a value, this is a referencing operator. So that is why you put a star here, and I'll explain maybe when we know more about pointers. I'll probably explain then what exactly the star operator does. But for now, just know that it gives the value of the memory location that we are referring to. So when you are writing a plus 3, that refers to the fourth element of the array, which is uh, the address of the fourth element of the array. And when I write star a plus 3, that basically gives you the value that is stored in that address. So it gives you the value of 40. Now what happens, so this is basically 40. Now what happens in this case? In this case you write 3 of a, but the compiler still sees it as this, right? And this is basically the same as this, because addition operation is commutative in nature. Sorry, it's associative in nature. I think that's the property. But anyway, so the meaning is that a plus b is same as b plus a. So that means if you write it in this manner, a 3 in square braces a, the compiler takes it still as star of 3 plus a, which is same as star of a plus 3. That and this is the same as writing a plus 3. So this is a valid expression, and it will give you the value at the index 3 of the matrix of the array. So here you will get a value of 40 as the output. Is that clear? Okay. So now that we have seen that, let's look a bit into strings. So we know that arrays can be of different types, like integer, floating point, double precision, and so on. So there is also a type of array which is called character arrays. That means it's an array of characters, and then you have strings, which is a little more than a character array. And we actually have a question. The right hand side question is actually explaining what is the difference between a string and a character array. So we'll look at that. But for strings, there is a whole other package that has been defined, which is this string.h. It's a complete header file in C where you get all these functions, predefined functions, which are available for string operations like string copying, string concatenating, and string comparing, and so on, and inserting to a string, checking the length of the string, and so on. A lot many operations related to the strings are available or are predefined inside this string.h header file. Um, so here in the first question, we have a few such operations being used. We are using operation which is strcpy, which is string copy, and strcat, which is concatenating strings. So the format for this is that for both of this is that uh, you write whatever strcpy or strcat, and you give the destination and you give the source. So whatever is in the source get copied or concatenated to the destination depending on what function you are using. So keeping this in mind, please try to answer the first question. That is the question on the left hand side. Right. So what happens here is that first, the innermost one is the strcat, that is the string concatenation. So in string concatenation, basically what will happen is that the string 2 contents will get copied after string 1. I mean, if string 1 is programming, then string 2, that is the language, will get copied just after this. So after this strcat, after this part is executed, str1 is basically now programming language, right? Right, this is what str1 becomes. And now we compare we copy it to str2. So like the source get copied to the destination, right? So now this entire thing is str1, which is programming language, like this, and that gets copied to str2 now, and str2, whatever the previous value is, it is discarded, and we have the new value, which is the programming language, which is this str1, get copied to the str2. So when and that str2 is finally getting printed using this percentage s, which is for which is the format for printing strings. All right, printing string data. Okay, so so basically we are printing str2 here because that is the destination one of the strcpy function, and here when we print str2, str2 basically has the value from str1, which is programming language. So the answer is option C in this case. Is that clear? Okay, so let's look at the next question. So this question basically highlights what is the yes, the array size will depend. I mean, the array size will vary depending on. I mean, yes, it will change, but there are limits to that. You cannot concatenate infinitely into a string. It is, and the string should have a capacity to handle the concatenation or the copying, whatever function you're doing. The string should have the capacity to handle that. I mean, there should. you should define a large enough string so that you can copy all the whatever I mean the size that you are concatenating, the final size after concatenation or copying or whatever final size is obtained, the string should be able to handle that. In some cases, if you don't ensure that it has a large enough size, it might give you an error. But in some cases, it might not. Why? Because, as I said, it's basically an array. So in an array, if you have the if you are trying to you're trying to define a larger size than you're trying to initialize a larger size or save a larger size data into an array, it will first check if there are empty locations available. If it is available, then it will work. If it is not available, then it will give you an error. So it can be a bit of a warning that you have to, and it's good practice that you have to keep a string size here to be large enough, the capacity to be large enough so that it can handle the all the letters after the concatenation or the copying function. Is that clear? Yeah. Okay. So let's look at the next question. So this question highlights that what is the difference between a string and a character array. So please try to answer this. So first of all, you can see how the definition or the initialization of a string and a character array differs. So the string is defined within this double inverted comma, and the character array is defined in the following manner that all the characters are defined separately. So you can see this I, L, O, V, E, C, and all the hyphens are defined as separate individual characters, which form each of those characters form one element of this character array, which is str2. But str1 has been defined in form of a string, which is enclosed in double inverted comma. So that is the difference in the initialization part of a character array and a string, and that leads to certain other hidden differences that we will be seeing here. So what should be the answer in this case? So here we have, let's see, str2 first. So we have how many characters? We have 8 characters, right? So total of 8 characters here. And this is empty. I have given an empty bracket here, empty square bracket in both of this. That means whatever the size of this particular string or this particular character array will be the same as whatever we are initializing it into that particular character array or string. Okay, so in the character array str2, we are initializing 8 characters here. So when we do the calculation for n2, so what will n2 be? So size of, if I let me just jog your memory, that size of basically is a special operator which returns the number of bytes occupied by the array, by the variable, not necessarily the array. So it returns number of bytes occupied by any variable or identifier. So using size of, you can simply write size of in bracket int, and it will give you what is the size of how many bytes does the int occupy in your computer. So it can be used in that manner also. So here when we calculate str2, when we calculate n2, what happens is we do a size of str2. Now str2 refers to the entire character array, and the every character, as you know, it takes 1 byte of space, every character. So one character, it takes 1 byte of space, and hence this str2, which is size of str2, will be 8 divided by str2 of 0, which is basically the letter I, which will take 1 byte. So you will have total of the answer will be 8 for n2. So but what happens in n1? So N1, when you do the size of str1, you will get, instead of 8, you will get 9. And however, str1 of 0, the size will still be 1, because that will still refer to the character I, and that takes only one byte of space. So your N1 will be 9 here. So here the correct answer would be option D. And why it takes 9 is because of the definition, in the way that a string is defined. So whenever a string is defined, for example here, so it is defined in this way. So basically there is a null character which is added to the end of the string, which marks the end of the string. So this, basically this null character marks that this string is ends here. This is the end of the string. So the string can be more characters after. I mean, you can define a string of 20 characters, I mean 20 capacity, but no, if you try to save a value, for example, here you define a string which has 20 capacity of 20 characters, but you are saving programming here. So programming is fewer letters definitely than 20, right? So you have 8 and 8 and 3. So 11 plus 1, 12 characters. So the rest, so the 12th character here, or if you start from 1, the 12th character here would be the null character, so that it says that after the null character there are no further characters, because you would get, if you try to print those characters, you would get garbage values. So when a null character is encountered, it basically says that that is the end of that string. So whenever we define a string or initialize a string, for example, in this case, another a special null character is added to that string, and that is what is happening here. So this are just the first part, which also was present in the character array, was 8 characters, but there is an extra null character here in the string, which will bring the character count to 9. So here you will get size of str1 is 9. Okay, so what is the doubt? Slash 0 is one of the character in any string array. Yes, in any if you define any string array and you are saving some data, some string data in that, so after that string data, automatically a slash 0 will be placed there. I mean, that is by default, the system will place a slash 0 to indicate the end of the string. Is that clear? Slash 0 is a valid character. It's a null character. It has a ASCII value, so it is a valid character in the according to the ASCII codex. Okay, so किसमें स्ट्रिंग टू में नहीं लगेगा, क्योंकि हमने उसको एक कैरेक्टर एरे के हिसाब से डिफाइन किया है. कैरेक्टर्स को सेपरेटली हम लोग इनिशियलाइज कर रहे हैं. मतलब हर एक कैरेक्टर को सेपरेटली इनिशियलाइज कर रहे हैं एज एलिमेंट्स ऑफ दैट एरे. सो देयर इज नो स्लैश जीरो that will be considered here. But if you write it in this manner in str1, the way that we have written, we define it, we initialize it as a string. The system automatically puts a slash 0 and at the end of the string. Okay, is that clear? Okay, so then we'll move to the next question. So this is what we will see what happens if we place a slash 0 in between the string. I mean, in midst of a string. Ideally, it's difficult to do this, but yeah, I mean, we can always try. So, what do you think should be the answer here? Right. So that is what the slash zero does. That is the null character does. So this is again, let me say this is a null character. So what the null character does it implies the end of the string. That is, when you try to print the string, it will print only till the character before the null character. So here it starts printing the string, it prints array, and then it encounters the null character, so it stops printing there. It won't go and print the, if there is anything after the null character, it won't print that. So here you will get just array being printed here. Okay, right. So I think if that is clear, we can move on to the next one. So this question particularly highlights the function of string compare. Like, how would you compare two different strings? Definitely you cannot compare strings by the double equals symbol, that is this. You cannot use this for strings. You can use them for other variables, but you cannot use them for string variables. So there is a particular predefined function in string.h header file, which is strcmp, which is basically comparison of strings. So try to answer this question. So basically strcmp will, so how strcmp works is that it compares one string to another string. So it compares string 2 to string 1, and it gives 0 if both are equal, and non-zero if they are not equal. Okay, so this is how string compare basically does, but there is actually a bit more, like this question is more focused towards what exactly will be the value in the non-zero case. Like, what exact output would you get, how to know what exactly is not equal in the string. So try to answer this. So first we are comparing the, yes, option B or D. I mean, I didn't, D. Okay, okay. Yeah, I mean, anyone else? It's partly correct, partly correct. Option D is partly correct. Uh, but yeah, I mean, yeah, it's partly correct. So that is the only option, right? If it's partly correct. Okay, so why option E? I'll tell you why it is option E. So let us first compare the str1 and str2. As you can see, str1 is A, B, C, D all small, and str2 is A, B, C, D with C capital, rest are small. So let me just write, yes, I mean, R is basically R is I mean, the string compare returns an integer value as the return value from string compare is an integer, which is 0 if it is equal, and if it is not equal, if the two strings are not equal, it is non-zero. So that is what I'm saving in R. Okay, so let me write down the two strings str1 and str2. So this is basically what str1, this is str1 and this is str2. So when I compare these two strings, what will happen, it will start comparing the first two elements. So it compares this to this, found to be similar, then just cancel them out, doesn't matter. Then it will compare the second character to the second character, same, cancel it out. Then it will compare the third character to the third character here, and it sees the ASCII value of the characters, right? To check whether the character are the same, it will compare the ASCII characters, I mean the ASCII values, which it did for the first two characters, and it found out to be the same. But in the third one, what happens is the first ASCII value here is 90, it's 97, so A starts from 97, so it's basically 99, right? Let me write that a bit properly. So basically here the ASCII character of small c is 99, and then what is the ASCII character of capital C? So from capital A is 65, so this is 67, right? So you get 32. So it subtracts whatever from string 1, which is the first argument, and the string 2, which is the second argument. So it will keep on checking each character, each corresponding character, the ASCII equivalents. It will compare them, and until they get the ASCII equivalent gets 0, it does not care. If there is a difference in between the ASCII equivalents, for example here, which it saw that the difference is 32 because small c ASCII equivalent is 99 and capital C ASCII equivalent is 67. So that gives you a value of 32, and that is what it will return to you. That means that means the first part, that the first output here is 32 that we are able to get. That basically what that represents is that whatever difference was there in STR1 was actually uh, because STR1 came after STR2. I mean, lexicographically, STR1 uh, occurs much later than STR2, and the difference in between them can be quantified as 32, and that is what here you will get unequal, that is non-zero, of course, as you can see 32, that is what you will get from here. And similarly, if you try to do the second one, that is what exactly the string 5 str5 gets copied to str4 because this is the source, this is the destination. So str4 becomes A, B, capital C, and capital D, right? And then you're comparing this to str2. str2 is still A, B, capital C, small d. So in this case, what will happen? It will just be the opposite. So small a get cancelled, small b get cancelled, capital C get cancelled. Now you see capital D. So capital D is basically 68 and small d is 100. So you'll get minus 32 here. So still non-zero. So it will basically the strings are unequal, but how unequal? Minus 32. So the answer here will be minus 32. So hence option C, option E. Is that clear? How this is happening? Okay. Okay. So let's move to the next question. So here we have another function which is basically how you input and output data as strings. So here you have you enter a string twice, and you have one entry done through percentage %s and the other entry done through get s function. So what should be the difference between this the first, sorry, not the print, but I mean if you try to print them or you try to see what the value are being, like what is the string being stored in them, what should be the difference here? Okay, yeah, that's correct. So say I entered programming in C, that is what I entered, and the first one, that is str1, will basically store only the first until the first white space is encountered. So it will just store programming, but str2, which is inputted using get s, will store the entire thing. Programming in C. So it will store the entire thing. That is the difference. And because getters will, as Rohit said, getters will finish taking the input when a new line operation or you press the enter key. It's a new line operation. So that is when the getters will get finished. But uh, the scanf will terminate actually much earlier once it encounters a white space. The similar kind of thing will be observed in case of printf and put s, which is the printing function for strings. So if you do a printf, it will print till the first blank space. I mean print percentage s, of course. So if you do this, you will get say some string, and here is string. Okay, so if you do this, you will see that it prints up till the first blank space, the print statement, but the puts prints the entire array until the null character is achieved or null character is found. So it will print the entire string. So that is the difference. So whenever you are trying to print strings or trying to take the input from the user and in form of strings, always use getS or putS. But even better, you can there are other functions, because there are certain issues with the getS and putS functions regarding an infinite buffer thing, but it's not really, very rarely happens that the buffer overflows. So if you enter if so in this case, basically in getS particularly, this is a if you try to print, you write a program in any compiler and you try to print something using getS, it will tell you that it's a dangerous function. Why it is a dangerous function is because it does not have any limit to how much it can print. So whenever a printing takes place, there is an output buffer or a printing buffer, and buffer is a limited space. I mean, it is a memory location, it is a limited space into which you can temporarily give some values and it will get stored in the buffer before getting printed. Now, here this str2 could be very long. I mean, you could give say thousands and thousands of characters in this str2, right? Which will lead to a overflow of the buffer. Now that can cause system to crash, because you are giving a much higher value of value to be printed than the buffer can handle. So there will be a buffer overflow. So that is why it says that the getS function is a dangerous function. So there are other functions that you can use instead of a getS function. I don't remember exactly the function, but in that, what you do is you give the string variable, and you also give the number of characters that is supposed to be in that string variable. So you give both of them as the input, as the arguments for that particular function. So in by doing that, you are making sure that you are telling that I need a size of this, so give me a size of this. So accordingly, you will be allocated space in the buffer. Okay, so yeah, let me just write this down. So this is a dangerous function. Okay, all right. So if that is clear, let us see the next question. Okay. Um, so in the next question, we have another string which is p, and it stores the word assignment, and then we are using this strlen function, which is basically the length of the string, that is the number of characters in the string apart from the null character. So strlen will give you a value of the string. Okay, yeah, I think it is apart from the null character. It will give you a value which is apart from the null character. Yeah, right. So so here in this case, you will have 3, 6, 10. So basically the strlen of p will be 10 for this case. It will give you the length of the string except null character. Okay, right. Now, keeping that in mind, try to solve this question. You said option B. Okay. Anyway, we will see. So before that, I was telling you regarding the alternative to the getS function. So we can use something called fgetS, where you will write the string, then the buffer size. Say you want to enter a string, like you are taking a string from the user, right? And you can say that the string can be a maximum, say, of 200 characters. maybe the user will not input 200 characters, maybe what the user has to input should be less than 200 characters. So you can say that my buffer size should be 200 characters. You just so you write fget as str comma 200. So you mention the buffer size, so there's no chance of a buffer overflow. But this is because possibility of buffer overflow. Okay, so this is an alternative option for the getS function. Okay, so let us come back to this question. So we have I equal to 0 and j is equal to 10, and the condition is I should be less than j. That means initially it is satisfied, of course. Then you have t, which is a character which represents p of I. In the first case, it's p of 0. So the first character a, and then you say that p of I is equal to p of j minus I. So basically what you're writing is p of 0 is equal to p of 10 minus 0, which is p of, I mean, right? Yeah. So 10 minus 0. So that means it's p of 10, right? P of 0 is equal to p of 10. So what is p of 10? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 10th, what is the 10th character? That means the 10th character is /0, right? If that is too small for you to see, I guess, let me just write it down here. So this is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. But what is the hidden 10th character? The hidden 10th character is the null character. Okay, so when we say p of 0 is equal to p of 10, so p of 10, that means the null character is getting stored in p of 0. So now what is p of 0? So the first character is /0, and then you have p of j minus I, that is p of 10 is t, which is the first character. That means you are exchanging the first and the first and the 11th character, right? So basically it now becomes /0 SSIGNMENTA. So this is what your string becomes. Then in the next step you have I++, and you exchange the second and the second last character of the string, which is second last character from 10. That means the ninth character. That means T and S will be exchanged. So you will have /0 TSIGNMENSA, right? Then in the next iteration, what will happen is /0 T, then you have n stored here, you have n, and this is the rest are the same, and instead of n you have s here, so SSA. Now in the next iteration what happens is so here j equal to 10, right? Yeah. So in the next iteration what happens is /0 t n, I is going to be replaced by e, so you have e here, and then g and m, this will be I, this will be SSA. Then in the next iteration you will have /0 t n e, now g will be replaced by m, and you will have m n g, right? ISSA, right? And then in the next one the n will be n will be replaced with itself, so it doesn't matter, it will still be the same for the next iteration. But by this time your I, what happens to the I? What is the value of I? So here I was 0 for this loop, this was 1, this was 2, this was 3, this was 4, and then you had another one where basically this n got replaced by itself, so I was 5. And what happens after that? So what happens after that is I is equal to 6. When I becomes 6, you have again what is the sixth character here? So Okay, let us again see this. P of 6, 0, 1, 2, 3, 4, 5, 6. So this is G. The sixth character is G, right? And that gets replaced with J minus I, that is with 4. That means again it gets replaced back. So G gets replaced back by M. And then in the next iteration, I will get replaced back by E. Let us do all that. So let me clear this space out a bit and try to write it down here itself. So we'll have slash 0. So this is slash. So T N E. This yeah, the sixth character 0, 0, 1, 2, 0, 1, 2, 3, 4, 5. Okay, am I doing this correct? So the character will be 0, 1, 2, 3, 4, 5, 6. Yes, this is fine. So as you can see here, the j value is not changing. So j is still 10. So I am just replacing I and j minus I. That is the index of the characters. So here again, g will come here and m and I s s a. So this is I is equal to 6. Now what happens at I equal to 7? At I equal to 7, you have slash 0. Then t. So here I gets replaced by E again. So T N I G N M E S S A, right? Then you have I equal to 8. So you have what getting replaced? The S getting replaced by N. So S getting replaced by N, you will have S here and I G N M E. This is S, this is S A, okay? Now that is I is equal to 8. What happens at I equal to 9? Now I equal to 9, you will have uh, S, is that right? Yeah, you will have T getting replaced with S, right? So in that case, you will have slash 0, T getting replaced by S, you will have S, S, I, G, N, M, E, N, T, A. So this will be your string. Now what happens after this? So after this particular iteration, I becomes 10, right? And once I becomes 10, it runs afoul of this, like I is no more less than j, because j is 10, so I and j become equal, so this condition is no more satisfied, the loop will exit. So this is where the loop exits, right? And once the loop exits, the final string that we had got is this. Basically this is our final string. Now if we try to print this, what should be the output? So as you can see here, so exactly, there will be no output because the first character itself is the null character. So once null character is encountered, the printing just stops. So here you'll get no output. Is this clear? How this? I mean, yeah, we did all this calculation, but there is no output finally because there is. If you had written I less than j plus 1 or less than equal to j, we would have got assignment as the output, because this in that case the loop would have gone on for one more iteration and this a would have been exchanged with the null character. But I less than j, you still, the null character is still the first character in the string, so we don't have any output in this case. Is this question clear? Okay, I hope it is. So I'll just move to the next question. So in this question, yeah, basically we have two different strings. Both P and Q have the same um, string stored in them, which is welcome. and we are comparing, we are doing a double equals comparison, that is whether it's equal to or not. We are doing a comparison whether if P is equal to Q, and if it is, then we are printing a certain statement. So what should be the output for this? Why do you say it will be compilation error? Okay, so what basically when you write an array, like I said, for any array, what does the variable, if you just write the variable, what does that mean? That means it is the address of the first memory location. So in this string you have something of this sort, right? So this is your string that is being stored in the system. Somewhere it is stored in the memory, and P is basically, and all of this are like this. Okay, I'm just not writing that. Okay, so P basically is the address of the first element of the array. Similarly, there is another in the memory somewhere. We are again storing welcome again. Okay, and Q is pointing to the first point, is the address. Q, just Q is the address of the first element of the array of this string. Okay, now when you say P equal to Q, that means you are comparing the address of this. So let me just write this as 1 and 2. So you are comparing the address of 1 to address of 2. Okay, but as you know, they have been, even though they have the same value being stored in them, they have been defined separately. That means they have separate memory allocations with different variables, which is P and Q. So they have been stored in different memory locations. So the address of 1 will never be equal to address of 2. So in that case, this condition is never going to be satisfied. So if the condition is not satisfied, it will just go and there will be no output in this case. Okay? But there will not be a compilation error because you are just comparing addresses. You're not comparing the strings. You're comparing the address of the first element of each of the two strings. Okay? So you're comparing the address of this W to the address of this W. So and it is found that the address is different, which makes sense because both of these are different arrays or strings which have been defined separately, and because they have been defined separately, they have been stored in different memory locations, right? All right, so here we are comparing the addresses. So what if we write this? If star p equals star q, what does this mean? Just go back to when I was explaining why a of 3 is equal to 3 of a, and try to answer. So this condition, whether it will be true or not here. So basically when I'm writing star of p, I'm writing this is basically equal to star of p plus 0, or I can write this as p of 0. Similarly, star of q is basically star of q plus 0, which is q of 0. So basically when I'm saying this, I'm comparing p of 0 to q of 0. That means the first value of p to the first value of the string of this string to the first value of this string, and both are the same character. I found out that both are the same character, they have the same ASCII equivalent. So in that case, this will be printed. Okay, so this will be a true. Let me not write this, this can be misleading. Yeah, so this condition, if I write it like this, then this condition is actually true, because this basically checks the first character or the value of whatever P is pointing to currently, the value of that to whatever Q is currently pointing to. So, and we found out that both are pointing to the first characters of their respective strings, and the first character is the same, that is, it has the same ASCII equivalent. So, for that reason, it will be true. This condition will be true if you write the star P compared to star Q. Okay, is that clear? Okay. Yes. As an integer, it might not print the address. You have to either print it using percentage %p, which is for pointer. I mean, for pointer data type, or for addresses, you can use percentage %p if you want to print any address. So you use this, and P or Q, this is what you would write: printf percentage %p, P. Then it would give you the address. Is it is it clear? Okay. Okay, so let's move on to the next question. So this is quite straightforward actually. You have a integer array, a 1D integer array, which is of six, which is containing six integers, and you are saving them as 1, 2, 3, 4, 5, 6, and you go from 0 to 5, and you have a m which is multiplying each of the characters. So basically, what what kind of code is this? This is a code to calculate the factorial. In this case, it's the factorial, but I would say it's not the code to do the factorial. I would say it is the product of all elements of the array, right? So it is basically product of all elements of the integer array that we are doing. And so in this case, because it's the elements are 1, 2, 3, 4, 5, 6, what should be the answer here? 720, right? Right. So basically here it is the factorial of 6. So you get 720 as the answer. But what does this do? What we are doing is we are multiplying all the elements of the integer array. So we are getting the overall product of the elements, all the elements of the array. Okay. Okay. So let's go on to the next question. So we have. So what would you place in the what would you put in the place of this stars here to print only this part? I want to print only this part, and for that, what should I put here? So can you answer this? Okay. So let me write this. I think, right. So this is the basically, okay. There is another slash 0. Okay. So let me write down the index. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are the indices. So when I'm saying just ARR, so ARR is this, right? Now I need to go to this. So if I need to go to this, that means how many I need to add it with? I need to add it with 6. So I need to write ARR plus 6. Only then it will go and point at this capital T. And once I, so here ARR 6 will be the answer, ARR plus 6. So that if I start at ARR plus 6, it will print the rest of the elements until this null character is encountered. So that is what I need. So I'll start from ARR plus 6. Here I'll write ARR plus 6 so that it starts printing from ARR plus 6. Is that clear? Why it will be 6, not 5? Okay, I hope that is clear. And then we have the next question where we are basically trying to swap two different strings. So what is happening here? Can you try to, you can try to answer this? Okay, but what is getting, I mean, what is the answer? There is a swap function that has been written to try to swap the two strings, but yeah, I mean, what should be the answer here? Okay, this might require a little bit of understanding of functions. I mean, okay, why do you think option A? I mean, can you tell your logic? Okay, no, but you are basically changing the address. Am I wrong? I mean, okay, let me. Okay, fine. Let us solve this question. It's fine. So you have this, and you have this. So this is str1 pointing here, and str2 pointing here. Okay, and slash 0, of course. So so str1 and str2 are pointing here, and I am passing those pointers, or the location of the addresses basically, to the swap function, which has been passed here. It is like to the swap function I'm passing um, the memory locations only. Okay, now this temp, what it does is it stores the memory location of str1. That means the memory address of str1. So the temp will, okay, maybe I should not have written here. So temp will also point to this. Okay, now str1 equal to str2. So keep in mind that this str1 and str2 are different from this str1 and str2, because these are the formal parameters and these are the actual parameters. So every function has a form, like when it is written or when it is called, the parameters or arguments that are passed through it, they are called the formal parameters, or the actual parameters or the actual arguments. And the arguments that are written in the function definition are the formal parameters. So they are not the same. In this case, only the name has been written the same. That is, you have given the same variable name, but um, this these are two different functions. So if you change str1 here, say forget about the pointer part for now. Say you had an int, simple int value. So if you change int of a here, whatever int a value is, yes, it is called call by reference. So basically you're sending the memory location. That is what you call by reference. I think while uh, it has been covered, or maybe it will be covered. So what is happening here, if there was simply an int of a, then whatever value you change in this a won't really reflect at the value of that, right? I mean, value of where it has been passed from, or what variable it has been passed from. It won't have changed that. So this str1 is not this str1. I mean, it contains the same data. Yes, it contains the same address of the first memory location, that is this s, but it is not the same. Okay, so to make things easier for you, what I will do here is I will write this as 3 and this as 4. Similarly, I'll just write 3 and 3, 4, 4. Okay, because it's not the same. Now let me rewrite it according to that. So this is 3 and 4. So temp points to 3, which is the same as 1. So initially str3 was the same as str1, that means the address, and str4 was the same as str2, the address. So temp points to str of 3, that means it points to, okay, let me write this as well. So str3, str4, okay. So this is how it is initially. Now temp points to the same address as str3, so this is how temp points. Now str3 points to str4, okay. So str3, instead of pointing here, str3 now points here, okay. Then str4 points to temp, I mean, now str4, oh my god, this is 2. Now str4 points here, because that is where temp is pointing, right? So str4 points here. But whatever the case, it doesn't matter, because they are simply different variables. So basically it is not swapping anything. It is not swapping any values or any uh, I mean, it is just changing the uh, it is changing the memory addresses. It's changing the what memory address a particular pointer is pointing to, which is also a formal pointer. It's not the actual pointer as well. So basically that is what is happening here. So str3, which was initially pointing to this capital S, ends up being pointing to the character 2, and str4, which was initially pointing to character 2, ends up being pointing to the capital S. But that does not really matter, because this function is not returning anything. If we had returned str3 and str4 now to some variable, and you said that yes, now those are the new memory locations that you need to use, then you would have said yes, the swapping process is complete. But here there is no swapping. Technically it is not happening, because this function is not really returning anything. There is no return. It's a void function type. So you are just changing this formal, how the formal parameters are pointing to different memory locations. You're just changing that. So this does not actually do a swapping operation. So when you print str1 is percentage str1 and str2, you get the same value that they initially had, which is SWAYAM and 2022. Is this clear? Mhm. Yes, it is an array type. नहीं नहीं वो array नहीं है. That is, whenever you talk about arrays, whenever, say if I write an array which is arr of 10, okay, that basically if I write arr, that is the address of the first memory location, address of the index 0 element, okay. So that is what I have written here. Then if you want the value of the index 0 element, if you write this, then this is the value of the index 0 element, right? So when you write this star temp, that is, you are defining a that is, it is a it is capable of storing memory addresses, and you store whatever memory address of str3 to temp. Then you write str3 is equal to str4. That means you're just changing the address. I mean, now str3, that is, it is a variable which can contain, which is a pointer which can contain the address of a certain location. That the address that it will store is that of str4. That means str4 is what? The address of the first element of that matrix, that is 2022. That means the address of 2. That is what the str3 will now store. So it's basically, you're just changing the address. You're not comparing or equating any arrays, but you are working with addresses here. Okay, and if you had placed a star, like if I had written star str3, that means it would have referred to this variable. Initially it was referring to this s, and if you had written like this str3 star str3 is equal to star str4, that means you are trying to swap this to I mean to set str3, I mean the first element, it was pointing to the first element, right? You would be trying to set it to 2. So here it would be 2 YM. Instead of SWAYAM, it would be 2 YM. Okay, so that's what would have happened in this case, but here you are just talking about addresses because you are writing it without the star. Okay, any other doubts in this particular question? Okay, okay, then let us move to the last question that I have for you, which is basically to check whether a matrix, a 2D matrix is symmetric or not. So here first I will ask the user to enter a matrix, enter the size of the matrix. So let me say that the matrix size is m cross n, and I've asked the user to input what is m, what is n. These are inputs from user. Okay. First of all, I'll just check that if it is square or not. If m not equal to n, then simply it cannot be symmetric, right? Because it's not square, it cannot be symmetric. So not symmetric. Okay. Now what happens in the else condition? I mean, when m becomes equal to n, that is, it is a square matrix. What should we do? So we will have the user input all the elements, right? We will have user input of all the elements, that is m into n, right? Or n into n, because m is equal to n now, so whatever. So you have the user input all of this. Then what you do, you have to check, say in a n cross n matrix, this is the diagonal. So basically you have to check this with this. I mean, say 0 1 2 3, it's a 3 cross 3. Let me consider this a 3 cross 3 matrix, which is easy to visualize. So basically I'm saying that a of 0 of 1 should be equal to a of 1 of 0, and similarly all others. I mean, this row should be equal to this column, and this should be equal to this, and so on. I mean, you understand the logic. Okay, all right. So I would use, say, I would count how many equalities are there. So let me set some count equal to 0 initially, and I start checking. So I go I is equal to 0, I less than n, I plus plus, then for j equal to not 0. Why not 0? Because I can just go to this part and check how many are there, right? So I'll just go with I plus 1 and j up to n, j plus plus. Why? Because I need to check only this upper diagonal part. I don't need to check even the diagonals, and so because the diagonals, whom will we compare it with? With the diagonals itself, which is definitely going to be the same. So we will just go to the upper diagonal part, I mean the elements above the diagonal, and we are going to check only those. So that is why I plus 1. So for the first row we'll check from 1 onwards, for the second row we'll check 2 onwards, and so on, right? So this is the diagonal element, right? You get my point. I mean, yeah, it's a bit messed up, but I hope you understand this. Oh, it's a 4 into 4 matrix. Okay, anyway, you do understand what I'm trying to say here. So so you go from I plus 1 up to n. Then what I need to check is if the this, let's say the array is ARR. So ARR of I of j is equal to ARR of j of I, right? 0 1 1 0. I'll check this. If it is so, then count plus plus, right? I'm increasing count by 1. So this is my entire for loop part. After this, what do I check? What should it be equal to? So say you have a matrix which is total number of terms n square. How many diagonal terms would be there? N, right? There will be n diagonal terms. Now subtract the n diagonal terms. Now what happens? What are the, so there will be equal number of terms left, which is the upper diagonal and the lower diagonal terms, because it's a symmetric matrix. So simply by 2. So this would be the number of elements above diagonal or below diagonal, right? Which is also equal above diagonal, which is also equal to the number of elements below the diagonal. So that is what we'll check it with. So now we check if count is equal to n square minus n by 2, then we say it's symmetric. Why? Because that means we counted the symmetric elements, and we found out that the count is exactly equal to the number of upper diagonal elements. So we say that it's symmetric. Else we say it's not symmetric. Okay, is that, yeah? And because else here basically means that m is equal to n. If you're going into the else part here, that basically means you're saying m is equal to n. So I don't need to do it for m, like it's n cross n matrix. Okay, so this is basically the algorithm for this, and this is the code. You can check this. So here I've done the same. The matrix dimension, I'm taking it as input from the user, and if it is not equal, if the matrix dimension are not equal, then it's not symmetric. If it is equal, then I am taking this matrix, which is I am representing by m at t and a count to be 0. Then I'm going to a loop and I'm saving all the data. I'm taking the input from the user, again the matrix elements. Then what I'm doing is I'm going and checking all the upper diagonal elements, right? All the upper diagonal elements, and if the upper diagonal elements are equal or symmetric to the, yeah, I mean it's the same. So m is basically equal to n, so you can do n square minus n. So this basically translates to n square minus n by 2. It's the same thing. It doesn't matter. So okay, so if I found the count to be the same as the number of upper diagonal elements, I would say that yes, the matrix is symmetric. Or if it is not, then it is not symmetric. Is this clear? Okay. Okay, so this was a sample problem for how would you check a 2D matrix to be symmetric. So that is all I have for this session. So we'll be okay. Count condition. Okay. Okay. So let's say we have a matrix which is m cross n, but we are saying that, see, we are saying in this else portion, right? So else portion, if it is square only, then it has the possibility of being symmetric. So m, once you go into the else condition, m is equal to n. Okay. Now let's say it is a n cross n matrix. Okay. So how many diagonal terms would be there? So number of diagonal terms would be n, right? There would be n diagonal terms in a n cross n matrix. Now total number of terms is n square. You have number of diagonal terms is n. That means I have subtracted the number of diagonal terms. So what would be left? The number of terms above the diagonal, number of terms below the diagonal, and that should be equal because the matrix is a square matrix. So the number of terms above the diagonal should be equal to the number of terms below the diagonal. So if I do this by 2, basically I'm saying this is the number of elements above the diagonal or the number of elements below the diagonal. That is what I have written here. So I'm checking if whatever count I have obtained, if it is equal to the number of upper diagonal elements, then it is symmetric. because that is what I'm checking here, the equality condition with their corresponding lower diagonal elements. Okay. All right. So that is all that I had for this session. So we'll meet not in the next week, but in the week after on Tuesday, uh, 7 to 9. Okay. Thank you for joining.